to Siddhantic astronomical texts, Paitamah Siddhant to Siddhant Siromani and its contemporary relevance. Today's speaker is Shri Somnath Chatterjee. He is an independent researcher of history and philosophy of science from Hooghly, West Bengal. I welcome you, sir. The National Mission for Manuscripts a mandate of documenting, preserving, and disseminating the knowledge enshrined in the manuscripts. In its attempt to disseminate the traditional knowledge enshrined in the manuscripts, the mission organizes the Tattvabodha lecture series since January 2005 in collaboration with various academic institutions. This lecture series provides insight into different areas of knowledge delivered by eminent scholars who are specialists in their respective fields. The Tattvabodha lectures create a forum for intellectual engagement and subsequently try to recontextualize the traditional knowledge to make it relevant in the present and future generations. The mission publishes a compilation of these lectures by the same name, Tattvabodh. Till date, 7 volumes of Tattvabodh have been published and made available online for public access at NMM website namami.gov.in. Last few days witnessed a series of important astronomical events which perhaps occurred after a long period of time. Lunar eclipse on 5th June, solar eclipse on 21st of June, and another lunar eclipse on 5th of July make it a rare event. We cannot have a better opportunity than this to listen about the astronomical texts associated with it. Most of you may be aware that the Indians excelled in astronomical calculations since Vedic times. Paitamah Siddhant is one among the 5 systems of astronomy, Siddhantica of Varah Mihir, compiled in 6th century. Others are Polis, Romak, Vasist, and Saura Siddhant. To navigate us through this journey of texts, we have with us Shri Somnath Chatterjee. He is an independent researcher of history and philosophy of science. As a project investigator, he completed 2 projects with INSA, Indian National Science Academy, New Delhi. He is associated with many learned societies. He has attended a number of national and international conferences, and his papers on Indian astronomy, education have been highly appreciated and published in reputed journals. Now he is working on conservation, editing, translation, and research based on manuscripts on science and astronomy. He has designed a unique course on manuscriptology, paleography, and conservation of manuscripts.
My dear colleagues, friends, all over India and abroad, I feel honored to deliver this Tattvabodha lecture on introduction to astronomical texts from Paitamah Siddhant to Siddhant Siromani in this platform of National Mission for Manuscripts. Before starting my lecture, I want to talk about this topic. You know, it is a long journey. From 1st century to 12th century, see, it is a very long journey. Before 1st century, what was the scenario of astronomical knowledge in India? There were eclipses, there were comets, there were sky events. To crack this historical problem, it is necessary to draw a backdrop. So, a few slides will be shown which will make the soil to start this discussion. This is a starry night. Studies all one Milky Way galaxy, which is called Chhayapath. I see. Wow, we are seeing. There are many stars, planets, etc. But what is the utility? When you look at the sky, it will tell you how small you are. You feel the sky is telling you, Aryabhat, Varahamihira, Brahmagupta, Bhaskaracharya spent many sleepless nights for the sky. They tried to explore my treasure. They had no telescope, no instrument to see far. Their beautiful eyes tried to touch the beauty and science of the sky. In India, manuscripts show that they had explored 5 planets with their own eyes. Akash bhara surya tara. My heart sings at the wonder of my place in this world of light and life, at the feel in my pulse of the rhythm of creation, cadenced by the swing of the endless time. Rabindranath Tagore. Akash bhara surya tara, bishwa bhara pran. Tahari majkhane আমি পেয়েছি মোর স্থান বিস্ময়ে, তাই জাগে জাগে আমার গান. What is astronomy? Astronomy is the science of heaven. It is the oldest knowledge of human civilization. In ancient India, Jyotisha, this term means both astronomy and astrology. But now, astronomy is the segment of science and astrology is treated as statistics. Astronomy is now divided in different areas as astrophysics, astrochemistry, astrobiology, observational astronomy, etc. Before Siddhantic era, astronomy was an observational science, and astonishingly, in ancient literature, in terms used to refer an astronomer is Ganaka, that is a calculator. So we can conclude that at that ancient time, astronomers only observe the sky. It is not true. They also calculate. In Brahmana literature, the term Nakshatra Darsha is found, which means stargazer. In Vedic times, people recognize 2 types of knowledge, Paravidya and Aparavidya. Aparavidya enables people to attain material knowledge, while Paravidya to knowledge only. Astronomy, the oldest knowledge of heavenly bodies, evolved to find right time for religious rituals, agricultural, need, and social festivals. It is a event. Just we have passed 21st June 2020, annular solar eclipse. This nice event we have experienced a few days ago, which are seen in ancient India only, ancient India too, Konkona Grasa. On the occasion of solar eclipse, the angular diameter of the moon less than that of the sun, so that the moon obscures only circular portion of the sun, leaving the outer portion of the such an eclipse is called annular solar eclipse. Now we have 7th century to 14th century, only 5 annular solar eclipse I have collected from Professor Balachandra Rao's book. Here, 3rd February 938 see maximum duration of annular solar eclipse is shown. We see that these shaded area, when so many times they cover, we see that it depends on the position of the moon. Now, it is diamond ring. It is another beautiful event at the solar eclipse we experienced. Now, a solar eclipse is caused under the following conditions: the sun and the moon must be in conjunction, and in the the new moon Amavasya must be close to one of the nodes, Rahu, which is called in ancient literature. This picture was captured on 24th October 1995. We have seen this diamond ring from Uluberia, West Bengal, from the bank of the river Ganga, not this picture. We have another experience in 2009, 22nd July. We went to Taregana, which is the birthplace of Aryabhat, to get an experience of total solar eclipse, but cloud betrayed us, so we can't see, we couldn't see. Now, a few total solar eclipse in history from 6th century to 11th century. Here also, we get the maximum time which experienced Siddhanta ceremony, time of Siddhanta ceremony, 21 hours, 56 minutes. Why study astronomy? Why study of astronomy started? But to make calendar. Okay. It is very important to prepare a calendar for a society, but long time observation is needed to prepare. Ancient civilization showed the patience, and calendar was formed in different pockets of the world. Sky observation was associated from the very beginning of cultivation and other activities. The stars and constellation, is it possible to make the diagram, the picture up and down? In the sky, as time passes, and by observing these parameters can make the calendars. The observed changes in the position of the sun and the moon were thus used to tell how the time progressed. All the observed that these changes were cyclical, which become as 1 year. Now, what are the applications of astronomy in society? Astronomy is now associated with different fields of life. International Astronomical Union, IAU, worked hard with volunteers from International Year of Astronomy 2009. They plan to link up astronomy education for culture, religion, language, mental illness, etc. But before technology comes, in our ancient culture, knowledge of astronomy was useful in our daily life. It was important, agriculture, it was important to know how the, okay, is it possible to, is it okay? Is it okay? Is it okay? Is it okay? May I audible?
Yeah, it's okay. You can continue.
Oh, now, the diagram obstacles are my slides. Okay, okay. Sowing, growing, and harvesting crops, and we at the right time. Astronomy provided information on determining the various rituals, as these times were linked positions of heavenly bodies in the sky. Sailors learned to ready the sky as practical solution to their navigational problems. They realized that stars in the sky provided them vital clues on directions. What are the sources of astronomical texts? Now, it is very interesting. Astronomical knowledge was transferred through dialogue of Guru Shishya Parampara. In Siddhantic texts, we see that Guru advised how astronomy should study. As for example, in Soma Siddhanta, sage Somnath asked the son of Brihaspati to tell something about astronomical events. In Brahma Siddhanta, in Surya Siddhanta, we have these experience. Sources of astronomical thoughts in India are inscriptions but small in number, and manuscripts huge in number. In this paper, I concentrate only Sanskrit manuscripts and Siddhantic texts. Before Siddhantic era, observation and calculation were in a mixed form. In India, astronomical texts, mathematics and astronomy were found side by side. In Jaina astronomical literature, canonical texts. Different form of manuscripts, the Sanskrit astronomical works of India divided in two main categories. One, Siddhanta, and second, Karana. This division is formed after Siddhantic era began. From Vedic time to beginning of Siddhantic age, astronomy was in a mixed form. Compilation of astronomical manuscripts. In 1966, a bibliography of Sanskrit works on astronomy and mathematics was published under the guidance of S.N. Sen with research assistance of A.K. Bagh and S. Rajeshwar Sharma. David Pingree made a wonderful job in 80s at last century. What is that wonderful job? David Pingree compiled Indian astronomical manuscripts with 5 scholars published by American Philosophical Society, Philadelphia in 2003. They divided the catalog in 10 sections. Siddhantos is one of them. A short account of manuscripts. India has a great treasure of astronomical manuscripts. Dr. S.D. Srinivas published a valuable paper on astronomical manuscripts from which I have isolated only Sanskrit manuscripts. In Kerala and Tamil Nadu, astronomical manuscripts which are edited, that number is 100 out of 934. In Rajasthan, Rohri, in the Asiatic Society, Kolkata, Mumbai, Bori, and many libraries of North India, there are many Sanskrit manuscripts which should be edited and translated. For the scholars throughout the world, transliteration is also useful. In Kerala and Tamil Nadu, catalog Sanskrit astronomical manuscripts, 2,990. Only original Sanskrit astronomical manuscripts found from 9th century to 19th century, 2,136. To make this paper, I have consulted 8 manuscripts. Astronomy in Vedic times. Astronomy in Vedic times, actually it is a large area to discuss. I have only point out astronomical knowledge existed in Vedic times. Nakshatras, planets, sun, moon, and their movements were observed by our knowledgeable persons. They noticed different events which were not natural. From fear, countrymen started to behave unscientifically. The Samveda and its Brahmanas and Sutras are very rich area of astronomy. The Nakshatras are doubtlessly mentioned in Rig Veda. Their whole series numbering 27 or 28 headed by Riddhis or Kritika. The Atharvaveda offers assistance towards our, it contains understanding the nature. It contains stray passages of astronomical consequence, such as the solar eclipse, and very important, the mention of Rahu notes for the first time in Atharvaveda. We find intercalation with a 13-month and a list of 28 nakshatras, including Avijit, Vega, Alpha. Vedic concept, example, sun. Actually, sun, after Sindhu civilization, Indus civilization, sun, Rig Veda concept about our universe is a new one. Our old literature notices that this art was made of Hiti of modern cosmology that also tells these 5 elements, but they say in different form. The sun, source of all energy, was treated as a player of various roles in nature. Today, we see that planets are living with sun. Without sun, our existence is zero. India originally had a lunar calendar in the time of Indus Valley civilization. In Vedic period, rectification started. The sun gradually became important, and consequently, lunisolar calendar was formed. I have here Rigveda 115.1, 105.5, 4, 542.7. These ideas are repeatedly expressed in several hymns. Actually, we know that various Vedic mythology and its various role in nature, sun is treated as a beneficial power. Vedic concept of sun's path, it is very important. Many scholars researched about the sun's path, ecliptic, or any other from Vedic literature. There are several references in Rig Veda and in the Brahmanas of the latter ages to the sun's path through the heavens. Boruno, the chief of the lords, according to mythology of natural order, had made a spacious pathway for the sun to travel. This path, called Rito, is easy to find. These passages have been interpreted in two ways. One, Weber regarded sun's path as the Milky Way. But scientifically, Ludwig and Hildebrand and other scholars regarded the sun path as the ecliptic. From the way sun's path is described, it is not immediately to associate it with the ecliptic. Such inference, Vedic people, knowledge of Vedic people and other. Uttarayana and Dakshinayana, just 21st June 2020, when we get the annular solar eclipse. From that period, that is the longest day, from that period, the sun goes to the Dakshinayana. Vedanga Jyotisha, very important Jyotisha Shastra. Actually, Vedanga Jyotisha is the first astronomical text we found. Two manuscripts have been studied on. One Rig Jyotisha, 36 verses, and two Jojush Jyotisha, 43 verses. From the second, we found the name Lagadha as a writer of the Rig Jyotisha. 20 verses of Jojush Jyotisha are same as the first. So, it can be concluded that the next one was composed after Rig Jyotisha, and the other proof is the name of the writer is found in the second. Except these two, Vedanga Jyotisha, Atharva Vedanga Jyotisha is also found. But this is not studied till now in detail. P.C. Sengupta, calculating nakshatra position, P.C. Sengupta suggested that Vedanga Jyotisha was composed in 13070 BCE. What are the characteristics of Vedanga Jyotisha? The excellent characteristics of Vedanga Jyotisha is 5-year Juga system. This 5-year Juga system continued up to Paitamah Siddhanta. It is very important. And Jain astronomers, I will see, they also accepted 5-year Juga system to make their calendar. This 5-year Juga system had an impact on Tibetan and Nepalese calendar and translated in various languages. Continued Vedanga Jyotisha, in other words, it is a new moon and full moon in Vedanga Jyotisha. Vedanga Jyotisha had followed the system of 27 nakshatras with names of earlier Vedic texts for finding the new moon and full moon. Vedanga Jyotisha took nakshatras as 27 equal space, but it is a peculiarity that each nakshatra segment was divided into 124 parts. These are not found in any other astronomical texts except Vedanga Jyotisha. Units defined in Vedanga Jyotisha: solar month, civil days, Savana month, synodic month, Tithi, intercalary month, Paksa or Parvo. Each synodic month has two Parvos. It is also the we found in Vedanga Jyotisha. What is the gap between Vedanga Jyotisha and Paitamah Siddhanta? It is 1370 BC and 80, approximately 80 CE. This large area of time, Vedanga Jyotisha influenced a long age in the field of astronomy. 5-year Yuga system was accepted by later astronomers, even by Jain astronomers. Jyotisha appears quite early in the history of literature and forms an important branch of their study. Surya Pragyapti, which is the source of Jain astronomy, the authorship has been attributed to Mahavira. The next important astronomer was Bhadrabahu, died 298 BC. Bhadrabahu accepted 5-year Yuga system and made a calendar which Jain rituals were followed. Surya Pragyapti adopted 5-year Yuga cycle. Actually, the difference between Jain astronomy and Vedanga Jyotisha is that full moon takes place at the Nakshatra Vihita. But in Vedanga Jyotisha, this full moon takes place at the Nakshatra Sravista. This is the difference only. The Surya Pragyapti contains the statement that the planets travel faster than sun and the stars, the sun slower than moon, and the stars faster than nakshatra. In Jain literature, the eclipse divided into 28 unequal spaces, which is very confusing to the next astronomers. Introduction to Siddhantic texts. The astronomical computations described in the Vedanga Jyotisha were in practical use for a long time. Around the beginning of Christian era, a new type of Indian astronomical literature called Siddhant emerged. The first century of Christian era is very important in the field of Indian astronomy. The word Siddhanta means final conclusion. Tradition says the older Siddhantas, 18 original Siddhantas, as Mahamohopadhyay Sudhakara Dwivedi in his Ganaka Tarangini, maintains the names of these Siddhantic texts. Most of them are lost. Only 5 Siddhantas are survived by Varahamera, included in Pancha Siddhantika. What are the contents of a Siddhanta? Why it is important? Why study of Siddhantic texts are important? Various topics in Indian astronomy are discussed in different areas. One, Madhyamadikara. Madhyama means the average. The average position of planets. Spashtadhikara, the procedure to obtain the true position of planets from naming position is discussed. 3, Prashnadhikara. This chapter deals with 3 queries: direction, dik, desha and kala. Chandra, Surya, Grahanadhikara. Computation of solar and lunar eclipses are discussed. Beside these 4 topics, many other topics are discussed in the Siddhantic texts. Now, which is the first Siddhantic texts we find? Paitamah Siddhanta. The other name of Paitamah Siddhanta is Brahma Siddhanta. In India, 4 manuscripts are explored in the name of Brahma Siddhanta or Paitamah Siddhanta. 1, Paitamah Siddhanta in Pancha Siddhantika, we know. Second, Paitamah Siddhanta is in Vishnu Dharmottara Purana. Third, Brahma Siddhanta in Sakala Samhita. And fourth, Brahma Siddhanta, which is Brahma's Photo Siddhanta of Brahmagupta. Albiruni, in his book, Brahma's Photo Siddhanta, he noticed as Brahma Siddhanta. What are the differences between Vedanga Jyotisha and Paitamah Siddhanta? Paitamah Siddhanta defines Vyatipata, which is absent in Vedanga Jyotisha. One. Second, first point of Nakshatra in Paitamah Siddhanta is Dhanishta, where Vedanga Jyotisha comes Avista. The measure of a year is more accurate than that found in Vedanga Jyotisha. According to Brahmagupta, the Paitamah Siddhanta contain the calculation, the positions, and of other planets, which is given in the which is not given in the Vedanga Jyotisha. Actually, the most important fact is that it is more accurate than Vedanga Jyotisha. But in Brahma Pancha Siddhantika, in 12th chapter, Varahamira, only 5 couplets are added as the Paitamah Siddhanta. Findings. According to teaching of Paitamah Siddhanta, 5 years constitute a Yuga of the sun and the moon, and Odimasas occurred after 30 months. And a lunar day, once in 33 days. Lessen the Shaka-Kring by 2 and divide the remainder with the remaining years. Find the Ahargana, continuing from the first day of the light of the Magha. The Ahargana thus found begins with the sunrise. After that, when we get the Aryabhata's calculation, we get Ardharatrika. Later Siddhantas. The general pattern of earlier Siddhantas is followed. That was substantial development in the matters covered. The reasons, the schools represented by the different came to be popular in different parts of the country. Actually, latter Siddhantas means Aryabhatiya to Siddhanta Sundara. Latter Siddhantas mean Aryabhatiya to Siddhanta Sundara. We get a main contributors in astronomy during the period 5th to 12th century. 1. Aryabhata 1, Aryabhatiya, Varahamira, Pancha Siddhantika Vyajataka. Here I only concentrate the main work of the astronomers. Brahmagupta, Brahma's Photo Siddhanta, and Khandakadaka. Bhaskara 1, Mona Bhaskaryam, Logu Bhaskaryam, Bhatteshwara Siddhant, Sripati, Siddhanta Shekhara, and Bhaskara 2, Siddhanta Siromani. Now, the imaginary picture of Aryabhata. I get it from internet, and one Aryabhata's Murti picture is in the Auka. Aryabhatiya. It is the earliest of the later Siddhantas. It contains 121 verses divided into 4 chapters. Chapter 1, Astronomical Constants and the Sign Tables. Dr. A.K. Bagh did a good job on sign tables. He has many papers on sign tables. It is very important that Aryabhat how got concept of sign tables, and he actually started mathematical astronomy in India. Chapter 2, mathematics required for computations. Chapter 3, division of time and rule for computing and the longitudes of planets using epicycles. The Armillary spheres, rules relating the to problems that of trigonometry and the eclipses. The Aryabhatiya started a new school of astronomy, which grew popular in India. India's first satellite, Aryabhata, orbited in April 1975, has got a great service to our scientific heritage. It popularized the name Aryabhata, a great mathematician, astronomer of ancient India. Aryabhata wrote Aryabhatiya at the age of 23. This is lost, but a revised version was written later. Bhaudaji, a famous physician and Indologist, based on his serious studies, published a paper on the Journal of the Royal Asiatic Society in 1865. Aryabhatiya published in different languages, French, English. A definite translation of this work was composed by Walter Eugen, a Sanskrit professor of Harvard University, and it was published by the Chicago University Press in 1930. From that very year, Aryabhatiya was studied enormously. Now, the available manuscripts of this work are available in different repositories in India. Theory of rotation of Earth, Aryabhata. Actually, Copernicus revolution, which we got in Western astronomy, in this area, from Kusumpur, a village area of Bihar, from Pataliputra, Kusumpur is very near. Aryabhata did a conception of rotation of Earth. In the first chapter of Aryabhata, he writes, in a yuga of 4324 years, the revolution of the Earth eastward is this. He says, the Earth turns through 1 minute in one prana. Please imagine, Aryabhata in the earliest 6th century, 499 CE to 502 CE, he observed sky, he conceptualized theory of rotation of Earth. This revolutionary concept of great author is relativity. These three verses are enough to show Aryabhata knew about the daily rotation of the Earth. These three verses. Now, Varahamira. It is also imaginary photograph of Ujjain. Why it is important? Varahamira compiled these 5 Siddhantic texts, which are the only documents of early Siddhantas. According to him, the Siddhanta made by Paulusho is accurate. Near to it stands the Siddhanta by Ramaka. More accurate still the Savitra, Saura Siddhanta, Surya Siddhanta. The 2 remaining ones are far from truth. That is, Paitamah Siddhanta, he did not mention an accurate Siddhantic text. The great scholar, the most renowned of the astronomical and astrological great scholar of ancient India. His works can be divided into 3 groups: mathematical astronomy, Hora, and Samita. The first one, known as Pancha Siddhantika, I mentioned earlier, summarized 5 Siddhantic texts. We imagined that those are available during his time and joined. His Brihat Jataka is a larger work of nativity, the Samhita, known as Brihat Samhita, a major work of astrology. The great influential mathematician and astronomer of 7th century, Brahmagupta. It is the imaginary photograph. Brahmosfuta Siddhanta, his great work. This Brahmosfuta Siddhanta had a great influence in the astronomical thought of Western and Northern India. He criticizes the views of some predecessors, Aryabhata, Balamir, Latadeva, Vishnu Chandras, Vasishtha Siddhanta, and Ramakrishna. He composed two great works. One, Brahmosfuta Siddhanta, which is a Brahmo Siddhanta, and the other is Khanda Khadaka. The second one was composed when he's 67 years old. It's okay. But Brahmosfuta Siddhanta, it is a large work. It consists 24 chapters, 1024 verses. These 24 chapters is divided into two main parts. First 10 chapters he incorporated astronomical events, astronomical knowledge, which are very common at his time. But in the next 14 chapters, he has treated more subjects. One chapter, that is 11th chapter, is found for criticism. He criticized rotation of Earth. He criticized Lato's astronomical texts, but he didn't criticize Paitamah Siddhanta. One deals with arithmetic and another with algebra, and one is instruments. The Deccan College collection has a copy of commentary by Holbrook, translated the portions dealing with arithmetic and algebra into English in 1817. This work was taken to Baghdad, where it was translated into Arabic under the title Al-Jij al-Siddin in 771 or 773 C by Muhammad ibn Ibrahim al-Fajari. Khanda Khadaka. It is very interesting book, divided in two parts, one Purva part, another Uttara part. The first part consists of 9 chapters containing 194 verses, and second part consists 5 chapters comprising 71 verses. The epoch of Khanda Khadaka is 665. All branches of the system which go to make the science of India appear to have been completely established in the time of Brahmagupta. Bhaskaracharya, the great mathematician and also astronomer. Bhaskaracharya was born in 1114 CE. It is the imaginary picture. Siddhant Siromani. Bhaskaracharya, a famous astronomer, compiled author is not found, no author is found. Surya Siddhanta, Soma Siddhanta, Vasishtha Siddhanta, Ramasa Siddhanta, Brahma Siddhanta in Sakala Samhita. Professor S.B. Dikshit, he wanted to make a new Panja Siddhantika. Surya Siddhanta is first, and then 4 Siddhantic texts which are the follower of Surya Siddhanta. Soma Siddhanta, Brahma Siddhanta in Sakala Samhita are the follower of Surya Siddhanta. Surya Siddhanta, according to Al-Biruni, this work was composed by Lata. But there is some confusion. According to Brahmagupta, the work of Lata is clearly said it is deviated from Surya Siddhanta. Brahmagupta criticized Lata's work in his 11th chapter. But Surya Siddhanta, referred to by Alberoni as compiled by Lato, was not original but the modern one. We know that in our astronomical heritage, we get two Surya Siddhantas. One is older and the other is modern. This modern Surya Siddhanta is influenced by Aryabhata and Brahmagupta's work. It is the most influential astronomical text. It is divided in 14 chapters, 500 verses. In the first part, time division and discussion of planetary positions. Now also, Surya Siddhanta influenced us to make Punjika, solar eclipse, lunar eclipse, astronomical instruments. Somo Siddhanta and Brahmo Siddhanta in Sakala Samhita, these are followers of Surya Siddhanta I mentioned. Traditional sequence of astronomical texts are followed in these two texts by peculiarity of Brahmo Siddhanta. Brahmo Siddhanta, what is the peculiarity? Peculiarity is this: various subjects are discussed in a single chapter, though it is the follower of Surya Siddhanta. But here is the peculiarity: various subjects are discussed in a single chapter, and some portion of third chapter discussed religious rituals, which is the part of Samhita, not Siddhanta. Somo Siddhanta contains 335 verses and Brahmo Siddhanta contains 764 verses. Now we see the another astronomical event, comets. Ramayana. When Ram Ravana were started, a comet was observed. Another reference in Ramayana, Rohini is covered by a comet. Dhukomanang Rohaneva Rohini Dhumaketuna. Just like a planet, it covers Rohini. In Mahabharata, the best known of all is a comet that was taught in Mahabharata. Why? This comet was observed in Mula constellation. Dhumaketu Mahagara Pushya, Pushya Nakata, Pushya constellation, Pushya Chakramma Tishtati. Now, in the field of observational astronomy, there are too many people who are known as comet hunters. Actually, I started my astronomical study from Halley's comet, 1986. We have observed in the late night in the east, tail of this Halley's comet, very, very beautiful. From that period, I have started astronomical study. What is comet? A comet is an icy, small solar system body that when passing close to the sun, warms and begins to release gases. A process called outgassing. This produces a visible atmosphere of coma and sometimes also a tail, which is very beautiful one. Eclipse, it is also a nice event. Aryabhata calculated exact time of Chandra Grahana. Story is that at that time, Buddhagupta was the witness of that event. Verse 37 to 44 explained lunar eclipse in his famous book Aryabhata, and the date and time, date 23rd March 517 C. Verse 47 refers to this partial solar eclipse also. After Aryabhata, in Siddhantic texts, eclipse was accepted, eclipse was explained accordingly. From Aryabhata to Siddhanta Siromani, in every Siddhantic text, we get eclipse is a chapter. What are the significance of Siddhantic texts? Actually, a very significant aspect of the period, 5th century to 12th century of Indian astronomy, was a remarkable development of new mathematical methods. It is very important. It is the actual milestones of Indian astronomy, this Siddhantic era. Now, the chief phases of the history of Indian astronomy are composed in Vedas, Vedangas, Siddhantas, E. Burgess and P.C. Sengupta translated Surya Siddhanta and gave notes, which is the actual inspiration of astronomical area. And more astronomical manuscripts. There are more astronomical manuscripts to be read and edited, which will change our history of astronomy. But it is a multidisciplinary task with a clear sky and good health. Thank you, Professor Jha. Thank you very much for this opportunity. It is not audible. You are not audible.
You can stop share screen.
Oh. Thank you.
Yeah. Thank you, sir, for your excellent presentation. This is I know that this is very vast subject, and you have covered it in such a short time. I hope once your detailed paper will come for the publication, the users will be able to gauge it with more details. So thank you again for your presentation. I also like to thank all the participants who joined digitally with this program. And the next session of the Tattvabodh lecture, the next episode, the 6th of July. So all of you are requested that with the next episode of the Tattvabodh lecture, we will join again on 26th July, Sunday in the evening. I like to thank also the members of the National Mission for Manuscripts and the IGNCA who supported me in conducting this event. I also like to thank the Member Secretary, Dr. Sachidanand Joshi, who has supported us in all these activities which we are doing for the at IGNCA and also at NMM. I also like to thank the NEJD team who supported us. Priya Sharma is here, and then their team, Sido Rao and Bhumika Suri. So their continuous support we are getting, and hope in the future we will also have the similar cooperation. So thank you, Priyaji and all his team. So with that, I will close this today's session, and again we will join on the next episode of the Tattvabodh on 26th July. Thank you.